All right, in the next part of the lesson, we're going to talk about synthetic division. Now, synthetic division is similar to long division, but it's going to be without the variables. So essentially, it's kind of a shorthand to long division, but it's only going to work if we're dividing by a linear term. So it's not going to work if it's an x squared or an x cubed. Okay. So again, our linear term, what we're dividing by, has to be linear. So we're talking about the second number, so this has to be linear. So if this has a squared with it or a power higher than 1, we can't use this method. Okay. Now I'm going to show you the general rules, and then we'll do several concrete examples. Okay. So to set up our synthetic division problem, we're going to start with a little half box up in the corner. And in this half box, we are going to write the 0 of what we're dividing by. Okay. So in this case, we're dividing by x minus e. So to find the 0, we take x minus e, we set it equal to 0, and we get x by itself. So that means that we would add e to each side. So x is positive e. So this is the 0. So that's going to go in here. Now directly across from it, we're writing the coefficients of all the terms, and if we're missing one, we still need that 0 placeholder, just like in long division. Okay? So the coefficients for this problem are going to be a, b, c, and d. And we keep the signs in front, so if one of them is negative, then we need to write it as a negative number. Okay? So again, this will be a, leave a little bit of space, b, c, and d. I'm going to leave a line here, the space, and then I'm going to draw my bar. And then we're going to start our process. Okay? So the first number, no matter what it is always going to come down. So this is going to be a, below the bar. And then we're multiplying. So anything below the bar, we multiply to the 0. Okay? And that's going to go here. Anything in between, we are adding together. Okay. So a times e is ae, and then we would add those together. So this is b plus a times e. And then now we're back to multiplying, so I'm going to take whatever this number is times a 0 again. So e times b plus ae, and then we would add those together. So this would be c plus e times b plus ae, and then we would add, or back to multiply, so this would go into its group, and then it would go here, and we would continue until we ran out of terms. Okay, so I'm not going to finish that problem, but that's the idea that we're doing. Okay. So if we do an example with synthetic division, okay, so again, we start with our little half box. This is the 0, so I'm going to take this x plus 1, we set it equal to 0, and we solve for x. So we're going to subtract the 1 over. So this will be x equals negative 1. So again, this is the 0 of what we're dividing by. Okay. So negative 1 goes into our half box, and then we're writing out the coefficients of each term. And again, if it skips a term, oops, sorry, this should have a squared with it. If it skips a term, we have it to have a 0 placeholder. Now none of those have skipped. So we would write 3, negative 4, 2, and negative 1. Leave a little bit of space, draw a horizontal line. Okay. First term always comes down no matter what. And then we multiply to the 0. So 3 times negative 1 is negative 3. In between we're adding, so negative 4 plus negative 3 is negative 7. Back to multiplying. Negative 7 times negative 1 is positive 7. Here we add. 2 plus 7 is 9. Back to multiplying. 9 times negative 1 is negative 9. And we add to get negative 10. Now we can't just leave our answer like that, because from long division our answer was always a polynomial. So our answer still needs to be a polynomial. So now we take these numbers and we're going to put them back into an equation. So the last number, no matter what, is always the remainder. Then you have your constant term, your x term, your x squared term, If we had more numbers, then it would be x cubed, x to the fourth. So we just keep going up by 1 power until we run out of numbers. So our final answer for this problem is 3x squared minus 7x plus 9 with a remainder of negative 10. And this would be our final simplified answer. All right, next problem. So again, we're going to do the same thing. We're going to start by finding the 0. So x plus 3 equals 0. So we would subtract to get negative 3. Okay. So in my little half box, that's where the negative 3 goes. And then we're writing out the coefficients to each term. If we're missing a term, we have to have a 0 placeholder. So first one is a 1. We're missing the squared term, so I need to put a 0. We're also missing the x term, so I need a second 0. And then 27. Leave a little bit of space, put our horizontal bar. First one always comes down. And then we multiply. Negative 3 times 1 is negative 3. Here we add, so that's negative 3. Then multiply to get positive 9. Add to get 9. Multiply to get negative 27. Add to get 0. So again, remainder, constant, x term, x squared term. So our final answer for this is x squared minus 3x plus 9, remainder 0, so we wouldn't write it. All right, last example using synthetic division. So again, I'm going to start by finding my 0, so 2x plus 1 equals 0. We would subtract the 1, and then we have to divide by 2. So this time our 0 is a fraction, so sometimes that happens, and that's okay. So we would have negative 1/2 in our little half box. Writing out the coefficients. Again, we need a 0 placeholder if a term is missing. So 2, 7, 3, 10, negative 5. Leave a little bit of space, put our horizontal bar. First term always comes down. Okay. So again, now we multiply. So negative 1/2 times 2 is negative 1. Here we're going to add, so that's a positive 6. Negative 1/2 times 6 is negative 3. Add to get 0. Negative 1/2 times 0 is 0. Add, so that's a 10. Negative 1/2 times 10 is negative 5. Add to get negative 10. So again, remainder, constant, x term, x squared term, x cubed term. So our final answer for this one will be 2x cubed plus 6x squared. We don't have an x term because it's 0, so we're not going to write it. Plus 10, remainder of negative 10. Final answer. Now this is the last part of our lesson, but in the next video I am going to talk about why division is important and why we're practicing how to do it.